We give the Baxter robot two skills. One skill moves a block from the right side of the table to the left side of the table while avoiding the phone in the middle of the table. The other skill moves a block from the left side of the table to the right side of the table and moves the block over the phone in the middle of the table. We give the robot the task of repeatedly moving the block between the left side and the right side of the table while never going over the phone in the middle of the table. With the current skills, this is impossible. We symbolically modify and physically implement the skills, rejecting any that are physically impossible. For example, if the desired skill has self-collisions as shown on the left. We get a modified version of a skill that moves the block from the left side of the table to the right side of the table and now avoids the phone. With this new skill, the Baxter is able to accomplish the task. Our second physical example is a jackal robot patrolling and reacting to a person. The robot initially has 4 skills, each of which are non-deterministic. The task is to always eventually visit region A, always eventually visit region D, always eventually, when there is a person, visit region E, and always eventually, when there is not a person, visit region F. With the given skills, the task is not possible because the robot cannot guarantee it will visit region E or F. The repair process suggests modifying 2 skills. One of the modifications is able to be learned, while the other is not. We run the repair process again and generate a second skill modification. With the modified skills, the jackal is successfully able to patrol and react to a person.